This video we're going to look at quality. You recall that quality is one of the project objectives, so it is rather important. It's one of the things we want to achieve. So quality has a lot of definitions. There's a lot of ways that we use it in language and stuff. So the way I'm teaching you here is the way we use it in engineering. And even in engineering there are different versions of the definition. So one is fitness for purpose. Whatever you're producing is fit for purpose. It does what it is supposed to do. So it's the ability to satisfy stated needs. So the client says that he needs a 4-lane highway, or says he needs a highway that can cater for 10,000 vehicles per day, and you design him a highway that does that, the 4-lane highway. If you design him just a single lane highway for 10,000 vehicles per day, it's too small. Okay, so the client will have their stated need, and it is the job of the designer to determine what that need is, and that's no small thing, and then design something that will satisfy that need. Now that's what the designer does. What the constructor does, what the engineers responsible for the construction do, is they construct what the designer has designed. So it's important that you understand quality for a designer is that he has found out what the client wants and he's designed something that will satisfy that need. For a constructor, they take that design and they produce it free from defects, deficiencies or variations. So in construction, project works are constructed as set out in the contract document. So most construction projects have a contract document, a tender document, which sets out in part the specifications, which are a written description of the workmanship and standards of materials, and the drawings, which show where everything goes. So they'll have the specifications and the drawings, and the job of the constructor, the construction engineer, is to construct it as shown on those drawings and as specified in the specifications. His job is to do exactly what is in that contract document, no more, because if he does more, so if they say they want a 4-lane highway and you build them a 6-lane highway, you're not going to get paid for those last 2 lanes. So it's going to cost you more as a contractor, but no less as well. If they want a 4-lane highway, you construct a 4-lane highway, not a 2-lane highway. If it says the lanes are 3.5 meters, you make them 3.5 meters. You don't make them 3.4. You don't make them 3.6. So no less means that if you do less than what is required by the contract document, you will not do the job, you will not get practical completion, you will not get paid for it. Having said that, the way it works in the real world is the designer will do a design, and then the contractor will get a hold of the specifications and contract drawings, and they will find that often they will find that the drawings, the design could be built a better way if it was slightly tweaked, if it was designed differently. Or it may be that the design doesn't quite work, it can't be constructed. So a good constructor will go to the designer or the client and say, look, we can do this faster and quicker if you do this bit differently. So they might specify a different profile of curb, and he goes along and says, look, we can do it quicker and cheaper using this profile. You still have the same effect, the curb will still collect water, but it'll look differently. Is that okay? And the client or the designer will look at what their needs are, and they'll say yes, it is. So remember, the consultant, the designer, is working for the client. So he'll say yes, it looks okay. He'll recommend to the client accepts it, the client says yes, that's okay. So the design in the contract documents can be changed with the designer, the client and the contractor all working together, and often is. But in construction, it is as set out in the contract document, or if you've agreed a variation, what that variation actually is. So construction quality, there is a couple of pipelines. The blue one's a water pipeline, the black one's a wastewater pipeline, and these are, I was actually the designer for this, and I'd put a whole lot of drawings and specifications there. So I had those pipes are sitting on bedding. I had specified what the bedding is. I'd actually drawn a picture showing where the pipes are, what the distance is between the pipes, how much bedding is underneath the pipes, how much bedding is going to be on top. You can see that they haven't put the bedding in yet. By the way, that orange there is ducting. So the contractor, the person that built it, would have looked at it and said, okay, have I got enough bedding underneath there? Are the pipes the correct spacing apart? He will also have said, is the pipe that's being installed as specified? I'd specified a 550 OD polyethylene pipe. Okay, is that 550 OD polyethylene pipe? He will have checked that. So that's another thing he needed to do to make sure that he was doing right. Is it at the specified level? Is it the correct pipe type? Is it in the right place? Looking at it in plan. Is the bedding material as specified? So I'd given them a grading curve for the bedding material. I didn't want sand. I wanted a gravelly sand. So had they actually provided that? So when it arrived on site, they needed to check that. So is it the correct pipe material? So in the specification, it specified that the pipe material shall comply with NZS 4130 using those sort of compounds. So is that pipe material the right type? He will have checked that when it came on site. He would have told the supplier that it needed to comply with that. So that's in the specification. Those are all in the drawings. So the drawings and the specification tell you how it's supposed to be, and it's the job of the contractor, the construction engineer, to make sure that it's done. So these are just for these pipes here. There's all these questions here, and you need to be doing checks and measures to make sure that you are actually answering those, saying, is it in the right place? Make sure it's in the right place. Is it at the right level? So you'll be doing all that. So there's a bit of surveying there. There's a bit of reading dockets. The pipes normally have the type written on them. There's a bit of measurement, all those sort of things going on. So there's a lot of things that the contractor needs to do to make sure that he is building it as required by the contract documents. And to do that, rather than just sort of rock up on site and sort of do it, right at the start when you're doing the planning, you set out a quality plan. So it sets out what the quality processes are, what's going to be checked, what is it going to be checked for. So is it a pipe? We're going to check the material, we're going to check the dimensions of it. What are we checking for? You will be checking the material, you will be checking the size. How is it to be checked? When is it to be checked? So when the pipe arrives on site, that's a good time to check the dimensions while the truck's still there. Okay, how is it to be checked? If we're checking the dimensions of the pipe, the thickness of the pipe, we'll use a vernier or a ruler. Who's responsible for checking? It might be the site foreman, it might be the project manager. How the results going to be recorded and stored. It's not good enough just to do the checks. You need to record them and store them, because at the end of the project the engineer is going to come along and look at those things and say, have you done all these checks? Can you tell me that this pipe that is now buried was the right type of pipe, was in the right place, it was at the right depth, it had the right bedding, it had the right backfill, all those sort of things there. Now he's not going to be checking all of those. The person on site did, the contractor and the engineer's representative, and they recorded them, documented them, put them in a folder, and that is what the engineer looks at. So the qualities will include checking the raw materials when they come on site, when they're on the truck. When you're halfway through it, so if you're doing, say, a reinforcing slab, you'll check the steel, you'll check the reinforcing steel. Is it at the right cover? Does it have the right spacing? Is it the right type of steel? You'll do that before you pour the concrete. Okay, because after the concrete's poured, it's very hard to check. And then you'll check the final concrete slab. You know, is it the right level? Is it the right thickness? Is it the right concrete? And if something doesn't come up to scratch, you'll also figure out what I'm going to do about it. Not just we'll fix it, it's how do I make sure that it doesn't happen again. So it might be that the reinforcing steel wasn't at the right cover because the people that put it in weren't informed properly. So you think, okay, well, we're going to make sure these guys get drawings next time. So here's a construction quality plan. This is the version I've used in the past, and we may use a different version this year. So there's columns there, so you're looking at what the item is referred to in the schedule of quantities in the contract document, what the activity is, and then what are we going to check for. So we're going to be doing all of these checks. How are we going to check them? When are we going to check them? Who's going to check them? And then the form will probably have a sign off that this person, I have checked the invert level every 20 meters, and they'll sign it off. So that's a very convenient way of presenting how all those checks that we're going to do in quality. So quality control is one of those things that us engineers do as well as safety. We're responsible for planning the quality, implementing it, which is what this plan is all about, and then checking to make sure that we have actually got it right. Because the consequences of not getting it right mean that we have to dig it up and do it again.